Lesson 11.5, Dividing Polynomials. To divide polynomials by a monomial, what you need to do is divide each term of the polynomial by that monomial. So, very simply, look at number 1. I have 2x squared plus 16x being divided by 2x. Okay, so let me write that for you. It's 2x squared over 2x plus 16x over 2x. So when we simplify, 2x squared over 2x is x, plus 16x divided by 2x is 8. And so x plus 8 is the resulting quotient. Right, number 2, I have b squared plus 12b minus 14 divided by 3b. So b squared divided by 3b plus 12b divided by 3b minus 14 divided by 3b. So let's start with the first term. B squared divided by 3b would give me b over 3 plus 12b divided by 3b, which is 4, and then minus 14 divided by 3b, which is 14 over 3b, because there's nothing to simplify there, and this would be your quotient. Okay, try number 3 on your own. Pause the video for a moment. Come back and check your answer. Okay, the quotient is 2r to the 5th power plus 3 halves r cubed minus r. The next type of division problem that you're going to see is dividing a polynomial by binomials. So what you need to do is first factor out any common factors, write the division problem then as a rational expression, and simplify. Okay, let's get started on number 4. H squared plus 9h plus 18 is being divided by h plus 6. So the first thing that I'm going to do is I'm going to factor the trinomial h squared plus 9h plus 18. Let's factor that using P&S, and by now you're an expert at this. H and h, and my numbers are positive 6 and positive 3. And that is going to be divided by h plus 6. We can cancel out the common factor and simplify. My quotient is h plus 3. Okay. Let's go on to number 5. B squared minus 2b minus 15 divided by b plus 3. So let's go ahead again and factor the trinomial. So my two numbers are negative 5 and positive 3. And we're dividing by b plus 3. So let's cancel the common factor. And my quotient is b minus 5. Now, it's not always that easy to divide polynomials by binomials, because sometimes there are no common factors. Okay? When there are no common factors by which you can divide, then we have to use the process of long division. But instead of just with numbers, we're going to use long division with expressions, polynomials. Okay? So you would set this up as you would any long division problem. Okay? Y squared plus 4y plus 12 divided by y plus 3. All right, so the first thing that you have to look at is, does each of the terms that is in the dividend, which is what's inside the division box, do you have descending order of the exponents? So I have y squared, y to the first, and then a constant. And there aren't any exponents that are skipped. If there were, we'd have to take care of those first. But there aren't. So we don't need any placeholders. Okay? So your first step is going to be, ask yourself, how many times does y go into y squared? In other words, y plus 3 times what number, or y times what term would give us y squared? And so because this expression has two terms, we're looking at two terms here. Right, so we know that y times y would be y squared, so we're going to place a y above that second term in the polynomial. Now, just like in long division, what you would do now is you would multiply y times y plus 3. Okay, so y times y is y squared. Y times 3 is 3y, positive 3y, but because we subtract here, immediately what I'll have you do is change your signs. Okay, so let's do y squared minus y squared, that cancels out. 4y plus negative 3y would give us y, and we're going to bring down the positive 12. Alright, so again you ask yourself, how many times does y in the y plus 3 go into y? How many times does y go into y? And the answer is one time, positive one time. Okay, so let's go ahead and multiply now 1 times y plus 3. 1 times y is y. 1 times 3 is positive 3, but because we're going to subtract here, we need to change all the signs. So y minus y cancels out. Positive 12 plus negative 3 is 9. And so we would have plus 9 over the divisor y plus 3. So your answer here is y plus 1 plus 9 over y plus 3. Number 7. 3x squared plus 9x minus 15 divided by x plus 5. Okay, let's set this problem up. 3x squared plus 9x plus 15 divided by x plus 5. Okay? Alright, so because this is a binomial, I'm always going to be dividing into a binomial. So let's look at x plus 5 goes into 3x squared plus 9x. All I need to focus on is how many times does x go into 3x squared? And the answer is 3x, because 3x times x is 3x squared. So now let's multiply. 3x times x plus 5. We're going to distribute. 3x times x is 3x squared. 3x times positive 5 is positive 15x. Normally I subtract here, so I'm going to change all the signs and add. So 3x squared minus 3x squared, well, that cancels out the 3x squared. Positive 9x plus negative 15x is negative 6x. Then I'm going to bring down the next term, which is positive 15. Okay, so now my next question is, how many times does x go into negative 6x? And the answer is negative 6. So negative 6 goes above the 15 because it's the term that I just brought down. Let's multiply. 6 times x plus 5, we distribute, would be 6x plus 30. Because I'm subtracting this expression, I'm going to change all the signs. I'm sorry, negative 6x minus 30 plus 30. Okay. Okay, when I distribute the negative 6, I have negative 6x, negative 30. But because I'm subtracting, I'm going to change all the signs. And let's go ahead and do that. Negative 6x plus 6x cancel each other out. And so positive 15 plus 30 would be 45. So I would have positive 45 over x plus 5. So my quotient here is 3x minus 6 plus 45 over x plus 5. Number 8. N squared plus 6n plus 2 divided by n minus 2. Okay, let's set this problem up. N squared plus 6n plus 2 divided by n minus 2. Okay, so again, this is a binomial. So I'm going to start here. Now I notice that I have descending exponents, n squared, n, and a constant. So I'm not skipping any terms there. So I ask myself, how many times does n go into n squared? And the answer is positive n. That term goes over the 6n. Okay, let's multiply. N times n minus 2. N times n is n squared. N times negative 2 is negative 2n. And since I'm subtracting here, I'm going to change all the signs. Okay, so n squared minus n squared cancel out. 6n plus 2n is 8n, and I'm going to bring down my plus 2. Now I ask myself again, how many times does n go into 8n? And it's positive 8 times. All right, let's multiply. 8 times n minus 2. Distribute and have 8n minus 16 because I'm subtracting. Change all the signs. 8n and 8n cancel out. Plus, that's going to be positive 18. So I have n plus 2 plus, because it's positive, 18 over n minus 2. So my quotient is n plus 8 plus 18 over n minus 2. Okay. Here we go. Number 9 is the last one we'll do together. Please notice on number 9 that my exponents go from exponent 3 to exponent 1. I'm missing a squared term. So here's what I need to do. I need to put in a placeholder. For example, c cubed plus 0c squared plus 5c minus 6. Okay? Because you need to account for every exponent in descending order. Divided by c minus 1. Okay, let's start dividing. C goes into c cubed how many times? Well, it goes in c squared times. So c squared times c minus 1. Distribute here. C squared times c is c cubed. And c squared times negative 1 is negative 1c squared. Since I'm going to subtract, let me change the signs. C cubed minus C cubed cancel out. I bring down 1C squared plus 5C. Okay, now I ask myself, how many times does C go into 1C squared? And it's positive 1C, or just C. Now let's distribute C times C minus 1. C times C is C squared. C times negative 1 is negative 1C. Again, because I'm subtracting, let me change all the signs and I'll add. So here we go. C squared minus C squared cancels out. Plus 6C. And let's bring down the negative C, 6. Now I ask myself, how many times does C go into positive 6C? And the answer is positive 6 times. So we're going to multiply now. 6 times C minus 1. 6 times C is 6C. 6 times negative 1 is negative 6. Because we are subtracting, I'm going to change the signs. And notice here, there's 0 remainder. So my solution is, or my quotient is, C squared plus C plus 6. Okay, practice a little bit independently. You're going to divide by a monomial, number 5 and number 14. Dividing by a monomial, remember you have to divide every term by the monomial. And then you're going to be finding each quotient either using factoring or long division. So do number 3, number 9, and number 13. All right, have a great night. God bless you. We'll see you tomorrow.